Hello, I'm Joanne Turner reporting for Total Telecom, and I'm here at the Huawei Global MBB Forum in Hong Kong, and I'm talking to Mr. Zhang, and we're in the 5G Enabling Technologies section of the exhibition hall here this week. Mr. Zhang, welcome and thanks for talking to us. So perhaps you can start talking to us about some of the 5G enabling technologies that you're showcasing here as we look to the vision for 2020.
Sure. Here we can see the first screen is going to talk about 5G network architecture, because we know that the revolution in 5G maybe first happen in the network architecture part. So here we will show that how we can use just one physical infrastructure to support multiple industries' diversified requirements.
Okay, and what about as we move sort of through the booth?
Okay, the second booth is about 5G revolutionary new air interface. Because we know that for the interface part, we have majorly two challenges. The first would be the flexibility, and the second one would be the spectral efficiency. And here we can see we have raised some new air interface technologies like filtered OFDM, SCMA, and polar code, and together with other massive MIMO and full duplex, such kind of new technologies, when they added together, we can meet the diversified requirements of different applications and also increase the spectral efficiency by at least 3 times.
Okay, and as part of the enabling technologies, you've got a sort of use case trial that you've got here from NTT Docomo. Perhaps you can tell us a little bit more about that?
Sure. Lately, this year, we have together with NTT Docomo doing some field trial on new interface technologies in Chengdu, China. And we have already verified all the new interface technologies like massive MIMO, FOFDM, SCMA, and polar code in Chengdu. And the results is really exciting. With the massive MIMO, it's just 100 megahertz. We achieved over 3.6 gigabps with 24 layers. And also for SCMA, and we achieved downloading for 3 times, 1.5 times throughput increasement. And for uplink, we achieved about 3 times connections increased. And it's really exciting results.
Okay, and on the ecosystem sort of use case side of the booth, you've got some interesting demonstrations there. Perhaps you can tell us a bit about those.
Sure. In their 5G ecosystem, you know that ITU recently have already defined the 5G requirements in 3 dimensions. The first one would be enhanced mobile broadband, which will require 10 gigabps and 3 times spectral efficiency improvement. And second one will be ultra reliable and low latency communications, which asks for 1 millisecond latency. And third scenario is about massive machine type communication, which asks for 101 million connections per square kilometers. And here we have 3 showcases or use cases demonstration about these 3 typical scenarios. The first one is about the enhanced mobile broadband. Here we are bringing the actual immersive video experience, the virtual reality, everywhere to this booth. And here we can see that we use 6 array cameras to shooting the real environment of the exhibition hall and transmit the video to our cardboard. And we can experience the VR here, and we see that for the future immersive video VR experience, maybe at least 4.2 gigabps required for such kind of BPS. That's why 5G need at least 10 gigabps throughput. And the second use case is about robotic arms. We cooperate with KUKA, and here we will show that the KUKA robotic arms with 1 millisecond latency control to do some remote control about the robotic arms. And the third use case is we are showing that in a typical scenario, for example, for the port, there are so many containers. When all the containers or all the other cars connected, there will be over 1 million connections in here. And that's how 5G will make this order these things connected. And also for the operators, they can use network slice to monetize the network capabilities. And this is a whole about our use case demonstration. Thank you.
Thank you for talking to us today. Thank you.
Thank you.